Okay, well, back. So, the issue. So we count these ones, and then we go through each edge. 1 to 10. And then we need to get the distance, the amount from both ends, don't we? So so if this edge is 10, well, I guess 11, and then we subtract it by the amount of the max moves. So 11 minus 5. I mean, what is it? 6? 6 would be 5. So we'd be left over with 5 nodes here, which is correct. And then we should get the one from the other side. Is that a viable solution? We say int res equal to 0, or int I equals 0, I is less than n plus plus. If dist I is less than is max moves, I think, yeah, it's inclusive, less than equal to max moves res plus plus. So what if we go 4 int edge edges? My only concern is I don't want to be well, actually, if we're going from edge, like edge to edge, we wouldn't be recounting, right? I hope not. This should work. I don't see why it wouldn't. Okay. So let's just say int left is equal to. Okay, let's do some. Int u is equal to edge 0. Int v. Well, this is a grid thing because it's bidirectional, but int w is equal to edge 2. So so we want to count the number of nodes. I feel like I should add something here to pass on nodes that are already too far, but I don't know. I might do that, but I'll do that later. So if the weight here is 2, then the number of nodes in between would be, it should be 1. So from 0 to 2 would be, I don't want to include the destination node either. How about this? If W is less, if W plus dist of U that doesn't seem right either. Alright, let's try it. If W plus dist U is less than or equal to maxMoves, so in this case, dist to 2 would be 2. So 2 plus 3 is less than or equal to. Now I'm regretting doing a bunch of this stuff with the weights. Well, I mean, I think I could just subtract 1 and call it a day, right? W plus dist U is less than or equal to maxMoves. Then we could just res this plus equal to W minus 1. Else int right UV is equal to I want to say so we want to get the number of nodes from W, but we need to subtract the amount that it took to get to dist U, right? Okay, wait. So if the current path here is 5, then from okay. So let's imagine first with 0, 1, 10. That would be we would want to add right we'd want to get the number of nodes minus the amount we currently have minus 1 minus maxMoves. Hell if I know. And then we'll just do this, but from starting at V. And then oops. I feel like that's not gonna work, but of course not. Minus 13. Minus 13. Oops. Oh. Wait. Okay, what if... to the 9. I suspect 1, 2, 3, 4, 5, 6, 7, 8, 9. Interesting. What the flip? Oh, it's probably this. That's probably not gonna fix it, but it definitely did not. Okay. This is great debugging, Kurua. So 3. Starts at 3. Okay, and then we add 1 from here to here. Well, that doesn't even... Oh. Wait, what different? We add 1 from here to here, which is weird because it should have started with here to here. That is very weird. It would be maxMoves minus W minus dist U minus 1. Bum 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 bum. Whoa, 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 what the fuck? Bum, 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 bum. Minus 5. Okay, it's great, but it's not. Maybe just flip this, John. Bum 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 bum. Bum 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 bum. Dun 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 dun. Okay, wait. Okay, what the fuck? Okay, I don't. What the hell? For some reason, UV is fine. Okay, that's definitely not right. Unless, wait, 10 plus 0, 11 minus 6 is 5. So maybe it should be this. It is now 4. What the flip? Huh? So if the weight is 10, well, it is 11 right now. So the amount of nodes we're actually working with is minus 1. Maybe. But then 0. So if we have 10 minus 6, that'd be 4. Oh wait, it'd be maxMoves minus dist of u. Wait, am I slow? Why would I? Okay. Okay, that looks right. That looks right. So why are you 15? And then 0. Am I recounting stuff? I think I might be. Bum 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 da 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 da. So we start out with 3 nodes that are just reachable, we know for sure. And then we have 6 from here to here, right? And then 1 from here to here. So then our second edge, 0 to 2, we have 10. Which means it just added fucking, I don't know. Nothing? What? Why? What the hell? It added 0. Okay, maybe that? I don't see how that would even... Okay, that's great, dude. I don't... This one just got lucky. So we should have added 1. And then from 1 to 2. Okay, now that's not right. So if the current weight is 2, 2 plus 3 should be... Dude, what the flip? This one is weird. Great. Okay. So we start with 3, we add 7 from this, and then we added 1 from here. Then from here it's trying to tell me that we're adding 5. Which isn't correct, we should be only be adding 2. So if W is 3 here... So W is 2. Wait, okay. 2. So if W plus dist then we should be able to... Why are you not doing that here for 1, 2? Dude. Three? That doesn't make sense either. What? 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 Oh wait. 1, 2. No! Oh wait, U plus... Okay, wait. 2 plus... No. Oh wait, hold up. What? 7? What? Oh, wait. It's because it's 1 to 2. Okay. That is awesome. First of all. Ah! What the hell? Okay, wait. What the... Okay. So because the edge is from 1 to 2, we want to think about this as 2 to 1 first. I don't know, dude. Math.min. Would that even work? I guess. But I have a feeling when I submit this, it's just gonna be like, but. It's gonna be but. Right? So 1, 2, 5, 0, 3, 3, 1, 3, 2. Okay, maybe instead of this, we'll have... Okay, so let's just say... UV is equal to math.min maxMoves minus dist u, or just freaking w, I don't know. Would I be recounting nodes though? Dun, dun. How the hell? Great. So I assume because these are both greater than, we're overcounting something. Maybe? Obviously not. Somehow this is 8 by 1, whatever. So the hell are break statements and whatever? I print everything. UV. So initially 3, so 0 to 1. We have 6 and then 1. That looks right. And then from 0 to 2, we added 1. That looks right. And then from 1 to 2. What? Where's the rest of you? So from 1 to 2, UV was 1. Oh, I see. Because of this. So this dist of dist of u is 5 in this case. So 5 plus 2. we not do this? Of course. So what am I not doing here? 0 and -2. Well, obviously that we shouldn't have negatives, so what the hell's going on here? So from 1 to 2, we have... Okay, I'm gonna draw this first of all. So we have 1, and then 2, and then there's 1, 2, 3, 4, 5, and then 0 to 3, and there's 1, 2, 3, and then 1 to 3 is 2, 1, 2, and then 2 to 3 is 4, 1, 2, 3, 4, and then 0 to 4 is 1. So what the hell's going on here? So from 0 to 1, it is... Ooh. Is it because it's out of bounds? maxMoves is 7, so 1, 2, 3, 4, 5, 6, 7. That in and of itself is out of bounds. Yes. And then 2 is way out of bounds. It's like if dist u or dist v is greater than or equal to maxMoves, or dist v is greater than or equal to maxMoves, can we just continue? Oh, obviously we should have this after the fact. Man. So from 0 to 3, we should add 3, okay. And then from 0 to 4, we should add 1. Great. Oh, but then we should be counting these. Okay, wait. 1, 2, 3, 4, 5, 6, 7. Maybe this. So from 2 to 3, we have so we added 3 properly, and then from 1 to 3 we added 2 properly, surprisingly. And then from 2 to 3 we have -2 and 3 when we should be adding 1, 2, 3, 4, 5, 6, 7. We should be adding 3. So what the hell's going on here? Right, because this thing is mad unreachable. So from here to here, we'd be doing distance to 2, which I would assume is 1, 2, 3, 4, 5, 6, 7, 8, 9. Or would it be 4, 5, 6, 7, 8? So this would be like 9. And then we'd subtract it by the amount of maxMoves. maxMoves in this case is 7. So we'd only be able to add 2, right? 1, 2, 3, 4, 5, 6, 7. No. So if this takes 4 moves, so we have 5 left, right? And on this edge we have 1, 2, 3, 4 nodes. Okay, simplify this. Dist. So yeah, okay. And then this one is 7, and then this one's 4, and then this one's 2 moves. So we made 4 moves here, and then we can make 5, 6, 7. So we'd have 7 minus 4 is equal to 3. And then here, because distance to this thing, oh my god, 9. Okay. So what if dist u is greater than maxMoves? Then uv is equal to that. Then let's just say vu. Would that work, please? 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 No. Okay. This is kind of promising so far. Oh, 44! What the hell is my problem, man? I don't want to draw all that. Okay. Don't save. So we have 0, and then 2, and then there's 1, 2, 3. And then 0 to 4 has 4 in between. And then 2 to 3 has 8. 1, 2, 3, 4, 5, 6, 7, 8. 1 to 3 has 5. Dude. Is there a graph visualizer I can use? Graph this. Here we go, this one. Okay, great. Is there a way to say weights? Okay, I'm not bothering with this. And then 0 to 3 has 9. Great. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 1 still. 1 to 3 has 5. Let's just put it over here. 1, 2, 3, 4, 5. And 3 to 4 has 6. 1, 2, 3, 4, 5, 6. And then 0 to 1 has 5. So let's pretend that's the real. Awesome. And then 2 to 4 has 6. Okay. 1, 2, 3, 4, 5, 6. And then 1 to 2 has 3. 2, 3. And then 1 to 4 has 1. Okay. So let's undo everything, I guess. It seems we're underreporting. So we start out with 4 reachable nodes, which means out of all of them, I'd assume probably 3 is not reachable. So 0 to 2, we add 3 properly. That makes sense. From 0 to 4, we'll add 1, 2, 3, 4 properly. And then to 2 to 3, we have 1, 2, 3, 4 moves, and then our max moves is 8. So then we can add 4 coming down here, and because of this, we can't like really move backwards. 3 is not reachable, so yeah. Okay. Should I even? Does that make a difference? Not really. Oh. Let's see how many more test cases. It's the exact same. Okay. But, so that seems to be good so far. So 1 to 3. 1 is reachable because we can go 1, 2, 3, 4, 5, 6, 7, 8. And that is exactly. But it says 2? Wait a minute. Oh, because we can go 1, 2, 3, 4, 5, 6. 7, 8. But we can't go from here to here. So that seems correct. And then from 0 to 3, we have 8. That makes sense. Because we can go 1, 2, 3, 4, 5, 6, 7, 8. But not. Okay, that looks right. 3 to 4. So we can go 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. And then 6, 7, 8. So that's 3 from 4. But again, we can't do that from here. So 0 to 1. Okay, that's just enough. So we can add 1, 2, 3, 4, 5. That seems reasonable. And then from 2 to 4, we have 1, 2, 3, 4. And then we can go 5, 6, 7, 8. Oh. Because. Okay, that. We can just add the whole thing. Wait a minute. Oh, we can't. 1, 2, 3, 4, 5, 6, 7, 8. So we can add 4 from this side. And then. And then we can add 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that added 1 extra unnecessarily. So what if we just did... So obviously, that... Duh! I don't know. Would that fix it? Okay. Back to submission. Okay, that really helped it. Oh my god. Output 1! Oh my god, did I just solve it? What the hell, man? What the what does that mean? Oh, Oh, you dick. Hey, oh my god, we solved it in pretty good time complexity too. How long did that take me? 46 minutes. I might have passed the interview if I wasn't ticking around. Hey, that was pretty good. Okay, so rundown. We do a dijkstras, right? And we want to get the number of nodes that we can reach initially. And then we'll go through each edge and like process those individually, see how many nodes in between each edge we can get. And we know that by kind of using the previous Dijkstra, what do you call it? Dijkstra answers. So if we can reach this node with this many moves, then the amount we can go deep in here is like, it's gonna be, well, obviously if it's within our allowance, we'll take the whole edge and then we'll continue. Otherwise, if it's not, we check if this thing, if we can come from either edge. We want to count from, I don't know, dude. I think I feel like I talked enough. I talked too much. Haha. Good day.